Hello, in this sixth video in the series I want to now talk about Boolean and comparison operators, which are not a hugely useful concept in, I guess, on their own, but once we start to combine them with future functions we'll look at, they really are key. They are really the glue for more advanced tasks. Okay, let's start by talking about, first of all, let's call them comparison operators. They're also called, I hesitated because they're also called relative operators and also relational operators. We've also got Boolean operators, which we'll look at afterwards. An operator is really representing a calculation in a formula. So we looked at operators in terms of the basic math symbols, so multiplication, division, addition, subtraction. These use symbols, and so operators tend to use symbols. For Boolean operators, don't use symbols. I'll show you them later. They're not very complicated, but they don't use a single symbol, which the comparison operators do, or two characters in some cases. But they both are related because both are to do with Boolean values. So Boolean values are when we only have two options. We only can be true or false. So we cannot be any other option when we have a Boolean value. So you can see when I typed it in, it went to capital letters because Excel recognizes Boolean as a data type. Boolean values are crucial in computing because computers use billions of tiny switches, like a light switch, called transistors. These fluctuate between being on and off, so electricity being on, being off, and this corresponds to, if it's on, it represents true, and if it's off, it represents false. And so the logic we can do with just true and false, we can also use in computers. Computers also use binary. Again, same idea. Binary is just being either 0 or 1. 0 represents false and 1 represents true. Obviously Boolean has it in its name, but both comparison and Boolean operators will evaluate to Boolean values, which means once we use them in a formula, the result is either going to be true or false. We're not going to get any other result. Although, like I say, 1 represents true and 0 represents false. Okay, let's just get this out of the way a tiny bit. We can just make it green. Why don't we set, to demonstrate this, let me just set a couple of cells or 3 cells with some numbers. Let's do 11 and 12 and back to 11 like this. And so first of all, let's look at comparison or relative or relational operators. These are there to just compare, as the name suggests, two bits of data. So are they the same? Are they different? Is one bigger than the other? And vice versa. So you would have come across them in maths. The most basic and most obvious is being equal to. So equal to. Are the two numbers you're supplying, are they equal to each other? So let's just do, and by the way, the operator for this is the equal sign, which is a little bit confusing because if I'm not careful, it's going to start to treat it like a equation. Let me just press enter or formula. Let's do a tab to get across. So let's try this in a formula. Start off with an equal sign. So that equal sign you start off a formula with is not equal to. I mean, it is in a sense, but it's not going to actually do any evaluation. It's just starting off a formula, so Excel knows. So now if I click cell B8 to reference it relatively, and then type equal, and then let's do C8 first of all. So 11 is 11 equal to 12. It should be not true, so I should get false. Once I press enter, I get false. So it evaluates to a Boolean value, false in this case. If I change this to what, so D8 is the same as B8, I should now get true. So relatively straightforward. Is the item on the left hand side equal to the item on the right hand side? The converse of this is not equal to. Let's just make this column a bit bigger. And this uses the less than sign back to back with the greater than sign, like this. So it's not just one symbol, it's really, well, it's one symbol but two characters, like this. And let's try it. So again, start with equals for a formula. We can try B8 is not equal to C8. This time this should be true because they're not the same thing, they're not equal to. But if I change it to D8, it does the opposite, it goes to false. And then I used those less than, greater than symbols. So let's use them on their own because we can do that too. So the greater than symbol is this, where we have the open end of a bigger than sign, and we have a smaller one towards the end of that sort of arrow. So now we can try this. So let's do is C7 greater than D8, C8, sorry, D8, press enter. This is true. 12 is greater than 11. But if I tried is B8 greater than D8, they are the same thing, we are going to get this to be false because B8 is not greater than D8, or was it the other way around? No, B8 is not greater than D8 because they're the same number. And so if we want to include, if they're equal to, we do greater than. And we do this by following the greater than sign with an equal sign. So reads as greater than or equal to. And this will work properly this time if we want this condition to be true. If I do greater than or equal to, and then D8, press enter, this will now be true. I don't think I necessarily need to explain this, but we also have the less than sign and the less than and equal to sign. Again, make sure the equal sign follows your symbol, it doesn't come before. You get a nice sort of arrow with this symbol, but not with the greater than or equal to symbol, but that's fine. Be working the same way. So is B8 less than C8, they are, so this will be true. And is B8 less than or equal to D8, again this will also be true because they're the same. So these are our 6 comparison operators, fairly straightforward. They're going to be used in wider formula and also used with our Boolean operators. So let's talk about these now. Okay, so our Boolean operators don't work like our sort of 1 or 2 symbol operators like we have with either just basic maths or comparison. These work more like normal functions. So we had power, we have our function name followed by brackets. Inside the brackets are where we're going to pass our values called arguments to be used in the function. And these operators work more like that. We have 3 operators or 3 basic operators for Boolean values, which are and, or, and not. So let's take not first. So what not does is reverses or inverts whatever value is being supplied to it. So if I go into this third column and do a formula, so equals, and if I type in not, I have uppercase or lowercase, then do brackets, and you can see it prompts us only to put in 1 value of data. Not only takes 1 argument, not 2, like the other 2 do. So now if I type in not false, press enter, I'm going to get true. If I typed in not true, I'd get false. It does the opposite of what we're going for. So I could put in one of our comparison operators. If I do, let's do B8 is less than C8, which is true, or should be true. If I do that properly, it's going to give us false though because we have wrapped that comparison inside a not operator. So we are evaluating the middle bit first in brackets. B8 is less than C8, which is true, but then not makes that false, which is why false is left to us in our cell. Like I said, and and or are a little bit more complicated only because they take 2 arguments, not just 1. So usually if we're doing this on paper, we'd write, argument A on the left hand side, then write and, then argument B on the right hand side. But Excel doesn't work like that because we have functions which are written like they are. So what and does, it needs both sides to be true for it to be true. Let's try this. If I do again equals and again type in and then brackets, and you can see now it asks for two arguments. And now with my first argument, let's use the same one before, B8 is less than C8, which we know to be true. If I do then a comma and add in my second argument, which let's do D8 not equals C8, let's use that again, close off my bracket, press enter, let's see what happens. So we get true here, let's try and figure out why. So first of all, the left hand side, we have B8 is less than C8, which is true. For the right hand side, we have D8 is not equal to C8, or D8 11 is not equal to 12, so this side is true as well. So both sides are true, and so the answer is true. Let's not do that. If I change this to be equals, B8 equals C8, this will go to false if I do it properly. I never learn. If I change this to equals and press enter, let's have a look. It goes to false because we have one side which is true, but that's not good enough for and. Both sides need to be true. Or is a little bit more forgiving when either side is okay. So we could have both sides being true, or one or the other could be okay. So if I try this one, let's do another quick one, equals or brackets. Let's just hard code this one. Let's do 5 is equal to 7, which is false. But if I do then 5 is equal to 5 and close off my bracket, press enter, this becomes true because 5 is equal to 7, which is nonsense, that side is false, but 5 equals 5, that side is true, and because or except either side being true, we get true as our result. So perhaps these operators on their own are not going to massively change how you use Excel or what you are doing, but as we use more advanced functions, we're going to need to use these more and more. These Boolean operators, and I guess for comparison ones as well, like I said right at the start, are more like for glue for more advanced tasks. They're not necessarily useful on their own in a tiny little formula, but if we can kind of combine them together a bit more. So if I do something like, let's start off with and then inside this I can have further expressions as well. So I could have an or inside, embedded inside an and. So I could have or, I don't know, let's just do something simple like false, comma, 5 is less than or equal to 6. That's also true. Not also true. That's true. And I can close this off. And then because I'm inside my and, I've still got a second argument to put in. So I do a comma, and now I can put maybe not in this one. I could do not 55 equals 65, which is not true, but because we have not, this becomes true. And now I've got to make sure I have enough brackets here, which I don't. I need to add one more. So hopefully you can see we have inside and, we have our first argument, which is an or expression. Then we have not as our other argument. So let's figure out what this will be first of all. So let's look at our first argument to and. So or false. So we have false or 5 is less than or equal to 6. So 5 is less than or equal to 6 is true. So we have false and true, and or returns true if either one is true. So this half of and is true. And over here, 55 equals 65, well it doesn't, but if we are doing the opposite of that, that makes this one true as well. And so because and needs both sides to be true, if I press enter, hopefully this will give us true, which it does. That's a relief because we had both sides, both arguments were true in this case. Okay, a fairly simple try now for this topic. First of all, have a look at these 3 formulae and have a look at my 4 cells I've set up the top and try and figure out what they would evaluate to. They're always going to evaluate 2 Boolean values, but see if you can figure out which ones. And question 2, investigate a 4th Boolean operator, which I haven't talked about because it's a little bit more niche, but try and work out in Excel what it does without actually looking it up yourself. Just play around with XOR, and the answers to all of these will be in the description.